Okay. Hello. Hello, good afternoon. Can you hear me? Okay. Hello. So, this is Junichiro Horikawa, and this is the Houdini Algorithmic live tutorial live stream for Houdini, which I've been doing weekly these days. And this is 124th episode for the live stream, and the topic for today is to procedurally convert an input geometry into some pipe like network like these. The method itself is not that special, it's nothing too complex. If you look at it really carefully, there are some intersections like these, so it's not really perfect, but at least it had some nice visuals if you look from far away, at least. So, and you could also change your input geometry to try out different visuals, like this one, like these, and so on. So in this live stream, I'm gonna show you how you could do such a thing, starting from an input geometry from scratch, right? So that's my plan, and hopefully you'll enjoy it. Okay, so as always, I am going to start from scratch. Okay. So let's start. Okay. Start by creating a geometry node, as always, since this is a modeling tutorial. I have a question. Will the pipe be intersecting each other? Some pipes are intersecting, and so in not correct way. So it's not really perfect. But as a practice for a vex, maybe it's might be interesting. So if you want to make it perfect to perfectly intersect to each other or bend in other directions, you might need to tweak a lot more by yourself, but it's gonna be the base that I'm gonna make is gonna be simpler stuff. Okay, I'm gonna use some test geometry to start off. I am going to use a rubber toy for this example, since I've already tried it. Now, first thing I'm gonna do is to, since I want to make a kind of a perpendicular, or also I want to make something like straight angle, 90 degrees angle pipes. So for this example, I'm not going to use any like any angles which is less than 90 degrees, like 30 degrees or 60 degrees and so on. I'm going to just use the multiplication of 90 degrees. So to make this input geometry simple, I'm first going to convert this into a voxel geometry. Okay, to make my life easier to align the pipe on it. So in order to make a voxel geometry out of the input geometry, I think there are a lot of ways to do that. One of the way I'm going to use today is to first convert it into a volume using such as ISO offset. Decide the resolutions here. This will going to be the resolutions for the voxel, the final voxel. Okay, so since these parameter could be used as a global parameter later, I might want to change those values later, so I'm going to create that as a global parameter. I'm going to create a null node named as controller and pass that information, which is this ISO offset division value, which is going to be used as the voxel resolution. Okay, let's say it's from 1 to 100. Okay, so that if I change these, you can change the density of the resolutions of the volume. Now, after I get this volume, I am going to place a point on each volume value, so that I could use it as a guide. I can use it as a base point for the voxel surface. So and I don't really need the infill, I just need the outer surface. So in order to just get the outer surface points for this voxel, for this volume, I'm going to use the volume wrangle to define where that is. Okay, so I'm gonna name this outer surface points. Hello everybody, thanks for joining. Okay, let me tweak my settings for the Macintosh a little bit. I'm seeing a lot of like window shifting a lot. So where do I change it? Okay, hopefully this will solve it. Okay, let me see. Now, where was I? Yeah, so I wanted to make a points for the volume, just the outside, just on top of the surface, which is on the threshold area where you have a density and zero density value here. So first you need to define the name of the volume. I'm gonna name it density, like a default value name. Then I am going to check if the current density at current voxel is more than 0.5. Okay, meaning if it is white or not. If it is white, it should be more than 0.5. If it is black or empty, that should be density less than 0.5. Okay, now I'm gonna search. If I'm looking at this point, somewhere on this point, I'm gonna look all the neighbors on left, right, forward, backward, and top and bottom, and see if the neighbor voxel has a density of 0 or 1. If it has a density equal to 0, then you're looking from the density equal to 1, so those direction is the position where you're going to have a surface wall for the voxel surface. Meaning, let's say if you have tons of voxels right here like this, and currently if you're looking at this point, which has the density equal to 1, and all those, let's say all those voxels which has the density more than or equal to 1 has the red value, and if the density equal to 0 has a white color value, then if you are looking at this point, and what I would like to do next is to compare the point between the neighbors, compare the difference of these density value. If the density is equal, like this one and this one, then you're not going to have any walls in between them. But if the density is different between this one and this one, like this one, then you should have a surface or a threshold wall in between those 2 points, which is going to be used as a voxel surface. Same for these one. And for this point, you're going to have a wall here and so on. So like that. So that's what I would like to do as a volume wrangle. Sounds simple. So what I just need to do is to create a loop to look for all the 6 neighbors starting from the x direction. So you have 2 loops for x, you have 2 loops for y, starting two loops for z. Okay. Starting from -1, I'm gonna use it as a directional value, so minus x direction and plus x direction. Same for all the axes. So let's name this t -1 t, like that. Okay. Now let's create a index value out of these values, out of these I, n, and t value here. First of all, the current index for this voxel. Index meaning is meaning the indices for x, y, and z direction for this voxel can be expressed as I x, I y, and I z. Right? Now, next I am going to create the points. Oops. I'm going to create the neighbor index by okay. Now that I think of, maybe I can just go with the first loop goes with -1 and +1, and the second loop could be a index for the vector, which could be written like these. So meaning if n is equal to 0, then that means x-axis. If n is equal to 1, then y-axis. And if n is equal to 2, then z-axis. In this case, you just need 2 nested loops. Yep, I think that makes more sense. Then update the n index for this vector value by adding the I value. So if you want to look for the negative direction, negative neighbors, you add -1. If you want to look for the positive axis direction, then you add +1. So since you have I equal to -1 or +1 in this loop. Okay. So this will give you a neighbor index value for the current voxel. Now you could get the density value from this index, vector index. So by using volume index function, looking for a density value index. All right. Oops, maybe I'm doing something wrong here. Preloaded shader is invalid. Something must be wrong. Okay. I was missing curly bracket. Okay. Now, now that I have this density value, what I want to do next is to compare this current density and the neighbor density here. So if the neighbor density is close to 0, then that means you want to have a wall in between those two neighbors or two voxels. Okay, so next thing you want to make is the point position in between those two voxels. So let's calculate, or let's get the point position at this neighbor voxel first by using volume index to position and using the density volume and index. Then you'll get a point position, corresponding point position. Now you have 2 point position at P and N pos, so that you could use a simple function or a simple calculation to calculate the point position in between those two. Add P and the neighbor point position multiplied by 0.5. Okay, and then let's try add this point to this position. Okay, so that makes it possible to create a point just outside the surface and not inside, because we don't really need the infill. Okay, so now that I have this point, next thing I would like to do is to use apply some normal direction so that I could use those points with copy to SOP node. Hello, Casalia. Is it I have a question here. Hello, is it possible to write wave function collapse algorithm completely in Vex? Yeah, I think it's totally possible. I did try that for 2D some time ago. It did took a little bit of time to think the data structures, but yeah, it is totally possible for sure. But using Python must be really much easier because you can just create your own data structure by yourself. But I think it is possible using Vex. But when it was okay using 2D for the Vex, but when it becomes 3D, maybe you might want to use Python instead because it's gonna be much more complex. Or even if you want to use it for hexagonal grid or more ambiguous grid like you see in Townscaper or something. Townscaper. So might be better using Python, but the speed might going to be also slow using Python, so you might need to choose whether you want to choose the complex data structure or simple code but slower version. Okay, what was I? So I have point. Let's set a normal direction. The normal direction could be a direction going from the current point position to the normal neighbor point position. So could just be a normalized n pos minus at p. Okay. And I might need to set the up vector as well, but let's try that later if I really need it. Okay, now that I have normal, let's also set a p scale to define the size of the plane that I should be placing on each point. So the size should be equal to the distance between the points, between the neighbors. So I'll just say npt lengths between the, or distance between n pos and at p, which should be the distance between 2 points. Okay, now I have this to attribute value on each point. I don't really need the volume anymore, so let's just delete the volume. Okay, gonna choose the volume. Now that I have points, just the points, which is wrapping the surface, and you don't really see any infill points, it's time you place the grid on each point to see if it could wrap up the surface like a voxel geometry. Let's make the grid size 1 1 and make the rows and columns 2 to make it simple. And let's see what's gonna happen here by using copy to points. Okay, so maybe the direction is a bit wrong for this grid. Let's change this to XY plane. Okay, it's close, but it's flipped. So one way to fix is to just reverse the grid here. Yeah, and that will fix it. Okay, and looks good. You now have a voxelized geometry which can be used as a guide to make a pipe. Okay. And I think the resolution right now is a bit too high yet, still too high for to align the pipe on each grid. So let's make it small as possible, like 20 for now. Later we're gonna change this value to test out more high-res version. But for the testing, starting with the low-res makes sense, I think. Okay, so now I have a voxelized geometry and seems to work fine. It's time we're going to create the pipe network out of this surface. Okay, so the method that I'm gonna use is kind of a simple. Things that I'm gonna do is to pick one of the strip, like this, on XYZ direction in any direction, in this direction or in this direction randomly. Just pick one strip. Then offset this surface to an outer direction a little bit. Then do the same again and again on each random strip, offset to the outer surface, also considering how much it offsetted last time so that it doesn't intersect to each other. And continue doing that until you decide until the number of pipes you want to create, and just combine them all together to make it as a something look like a weaved pipe. It's not really weaved because you're just offsetting the surface and aligning the pipe on top of the surface. So it's not the real weaving, but by picking up random surface one by one and changing the offset value for the surface, it somehow looks like it's being weaved. So that's my method. Kind of a brute force way to create a pipe network, but as a visual it looked fine to me. So, and it was a good practice for me to use Vex for those procedures process. So I'll show you how I did that. So to do that, the first thing I would like to do is to just pick one strip and then offset the surface. And I want to do this like as a feedback loop one by one. If I offset the surface, then in the next loop I want to pick another strip, then offset, considering the offset that I did last time. So to do that, I'm going to use a for each number. On each loop I'm going to pick one of the strip, then try to offset that surface. So let's do that. Okay, first I'm going to set up the loop so that it become a feedback loop. Oops. So first I'm going to make it as feedback each iterations. Make this one to feed. Oops. Why do I having? Okay, let me just change the settings for this Macintosh so that the display wouldn't disappear when I touch the corner. Okay, so how do I do that? Forgot. Control center, was it? Totally forgot. Okay, got it. Okay, now it should be fine. Sorry. So make this feedback, fetch feedback. Okay. So this is the most complicated part for this live stream, this tutorial live stream. So bear that in mind. First thing I would do is to pick a random strip on some direction, either X direction, Y direction, or Z direction. Okay, so let's do that. I am going to use again a Vex wrangle to do that. So, and to just pick a strip by using one vector as a reference, you do need a little bit of vector calculation or vector mathematic. So let's see how I do that. First I'm gonna get the primitive wrangle. Then since I would like to pick the strip randomly, I am going to also refer to the iteration value from this count node. Get the iteration value like that. Okay, now let's see. First of all, gonna have to decide which direction I want to use, right? Either x direction, y direction, or z direction. Okay. So what would be the best way to do that? Well, I think I need a random value to do that first. So let's create the random value, or random index value, I guess. Oops. For the direction, so rand direction is equal to random iteration multiplied by some threshold value, or some random value. And probably if you want to change the random value by yourself by setting the seed, you might also want to set the seed by yourself. Okay, and this will give you just 0 to 1. So, and the value that I want is either 0, 1, or 2, since the direction is either direction is in three axis. So I will multiply this by 3, I guess. Okay. And use floor to convert it into an integer value, so that you have 0, 1, or 2 in this case. Probably. Yeah. Okay. So now that I have this index value, let's create let's just call this random index, and let's call the vector value as random direction, starting from 0. And I'm going to use this random direction index as an index value for the vector value, just like this. So if it's 0, then you're accessing to the x coordinate. If this is 1, you're accessing to the y, so on, and make this 1. Okay, so that should make the direction either x, y, or z. All right. Now it's time you use this to get one of the strip. So in order to get the strip position, you also need one more information, that is the point position, random point position on a space where it'll be used as a guide point to make it as a center of the plane. So if I explain it in Sketch, let's say you have bunch of grids like that, and currently you have a direction, the random direction, that this could be either this way, or three-dimensionally a depth direction. But let's say this is the direction that I have right now. Now the next thing I would want is the point position of the plane made by this vector value. Meaning if you want to create a plane out of this vector, the plane looks like a perpendicular grid, like that. So using the directional vector value as a normal value for this plane. And by using this plane, you can slice the strip by just providing the vector value and the center of this plane. Okay. So what you need is this point position, which could be somewhere here or here or here, anywhere, which is on this line. If you place the plane position to here, then the plane will look like this, and what you get is this slice. Okay, so that's my plan. And to do that, you could randomly specify the point position on a space. So let's create another random value. In this case, I'm going to call this as random position, and using again the iteration multiplied by some other value plus seed, which currently gives you a value between 0 to 1. So if I want to make it as the value in between the minimum bounding box of this geometry to the maximum bounding box of this geometry, I would need to first calculate the bounding box information out of this geometry by using get bbox like this, then fit this function, fit this random value. I'm gonna do this in the next line to make sure this will become a vector value. The random position is fit 0, 1, random position min max, to make sure that the point will be always inside the geometry. I mean, not inside this boundary box of this geometry, which could be somewhere around here, could be somewhere around here, but will always touch some place using a plane. Okay, so now that I have a point position as well as the random direction, I can now define the plane information, and it's time you calculate which grid belongs to which grid can be sliced with this plane information. Okay, so let's see how we do that. Okay, going back to the sketch. Let's see what kind of calculation I need to do. So I have now a point position and a direction, and I have a bunch of a grid. Why did I make it diagonal? Okay, so I have point, direction, and I have bunch of grid to check whether it's been sliced by the plane or not. Okay, so what I could do is to calculate the normal, this directional distance, meaning I could project each center point of this grid to this vector value. And if I do that, if I project this point, then the point will come here, and now you can calculate the distance between the center point of this plane to this projected point D. And if D is larger than the half size of this grid, which I can say T, if D is more than T, then that means the point is outside this plane. Outside is strip, so this point cannot be included as a strip. If you look at this point projected on this vector value, the d will gonna be less than t. In those cases, you could include those plane or grid as a part of the strip. And in order to project and calculate the distance, you can just use a dot product. Just normalize this direction. Normalized direction. I'll call this B. Then calculate the dot product with vector value going from this point to here. Then you can calculate, let's call this, I don't know, A. Then the result will be this distance value. Okay. So the equation itself is pretty easy, you just need to do that. Okay. But the thing is, yeah, that should do the job. So let's try. So, thing is, the dot product could be a negative value if you are projecting to the negative direction of the vector. So you gotta need to calculate, you gotta use the absolute to make the final dot product value positive. So let's calculate that. The distance is equal to, first of all, let's create a vector value. Vector A is the current point position of the primitive minus this random position. Okay. And the random direction is like this one, but yeah, this is the axis information. So now you can calculate the distance using dot between the random direction and the vector A, make it absolute so that it will become a distance value. Now it's time you specify whether it's less or larger than the half size of this grid size. Now where do I get the size of this grid size, which is equal to this p scale that I have here on each point. This one. So let's pass that to a primitive attribute so that I can use it. Now, can we do that here? Not sure. Primitive, copying, or yeah. Now I can copy the p scale coming from the point to the primitive, and should be usable inside this loop. If I look at the primitive or not, yeah, now that I have it here, I can now access it to use it as a check-in value, a threshold value, to check whether this distance is larger or smaller than that value. So if distance is less than p scale multiplied by 0.5, the half size of the grids, then that means it should be the strip that what I want to pick up. If not, those are not the strip that I want to use. So let's just try checking it out by coloring the strip geometry with some red color. And do we have it? Yup, like that. Okay, and let's try changing the random seed value. See if this is working. And yeah, I think it is working. Now, one problem here, I am getting the side color, side information as well. I mean the side surface as well. So that I don't really want to include these. So maybe I need to make this threshold a little bit smaller, like 4.9 or not. If I make it 4, maybe not. Okay. If I think about this point, so if this is the point position, okay. So maybe I also need to consider whether this direction, this is perpendicular, this is equal to the direction which I've defined here. So if the dot product between the normal of this face and this direction is equal to 1 or equal to -1, then I shouldn't include that as a strip. So I'll make another conditions dot between the current normal, which I also need to create the primitive normal directions here in order to check if the primitive normal and the dot product of current normal and the random direction is less than 1 and has to be absolute. Less than 1 or less than 0.5. That's the strip that I want to pick up. Okay. Should do the job. And yeah, I think it's now working fine. Okay, looks good. Now, next thing I'd like to do is to just pick the red part, the strip part. So I'm just gonna delete all the other stuff. So, or else, just remove the primitive. Like this. Okay. And the next thing you want to do is to offset this surface to the normal direction and continue doing this until you get many numbers, a multiple number of strips out of the loop. Now the problem with this loop right here is because I'm using the feedback loop, it's trying to use the result of this strip as the next geometry, so I need to fix that a little bit. For the next loop, I want to use the original geometry, which is this one, to pick another strip. But I also want to keep these strip inside the loop because I want to use it as a guide for the next loop. So to do that, for the original geometry, I'm going to apply a group named as guide. Okay. Then the strip geometry, for the strip geometry that I have here, I'm going to remove the guide add in the group. Group, delete, this primitive, and then I'm going to merge these two information. One is this guide geometry and one is this strip geometry together. Oops. And the strip geometry actually needs to be created from the guide geometry. So I'm going to just pick the guide using delete and use that to create additional strip. Okay, so that should give you a bunch of strips. Let's try changing the color for each strip to make it easy to see the differences. So I'm going to make this random based on the iteration. So random iteration multiplied by another value like this. Okay, so you can see multiple strip has been created, and in the end you can delete the guide geometry here to just get the strip like that. Alright, should do it. Now next thing I would like to do here is to offset each strip a little bit so that the strip wouldn't intersect like this one, like these yellow strip and green strip are being intersecting in the exact same position, so I want to avoid that as much as possible. So in order to do that, I'm going to offset a little bit based on the pipe thickness that I'm going to place on each strip. Okay, so to do that, I want to define the thickness of each strip, which is going to be used as the thickness for the pipe later, and use that thickness value to offset the surface. And I want to preserve that information to the next loop so that I could calculate the new offset value for the new strip so that it's not going to touch the previous strip geometry as much as possible. Now the calculation isn't perfect. If you offset the surface a lot of times, then it's gonna self-intersect at some point. So in those cases, this avoidance, it's not gonna work anymore. So it's not that smart way to do, but at least it does have some effect for initial tryout. So as an initial step, should be fine. Okay, so let's do that. So in order to do that, let's see what I need to do next. First of all, if I check the original guide geometry and double click the grid, it's not selecting everything because every point is being separated. Every point is unique, meaning the point is not fused. So let's fuse this first to make sure every point is being merged. So right now, after fused, you have 652 points. Before you had 2600, so the point has been merged, and if I double click it, every surface is connected. And okay, so this is better. Now going back to the strip, now if I double click, I need to enable this one first, check this one. If I double click it, okay, everything is selected, meaning everything is being connected at this moment. Okay, so let's think how I should offset this surface. Now, the method that I would like to use next is for each strip I want to look for the original guide geometry. And see if there is any previously offsetted strip. For example, in this case, these areas. If previously there is a strip placed like these, you can see that there's an intersection here. So to prevent touching the pipe to each other, I want to offset this part a little bit to the upper direction. So that it's not going to touch the blue strip. But I don't actually need to offset the other surface, like these one or these one. I mean, I do kind of a need to offset this one, but I'm just going to ignore that for now to make it simple. For the other surface, it's not touching to the other strip, so I don't really need to offset these. So what I want to do is to just offset the surface which is touching this blue strip, okay? So that you can avoid offsetting the other surface to just inflating strip on each loop, unnecessary inflation. Okay, to make the pipe network as packed as possible. Okay, so that's what I would like to do. And in order to do that, you need to give the original geometry the information how much each how much of each surface has been offsetted by a strip. So to give that kind of information, I'm going to create some additional primitive attribute to the original guide geometry. Now from this part, it's going to be a little bit complex. So I'm going to use attribute create, then create bunch of information. One is how much the surface has been offsetted for the strip. So I'm going to name it as offset size and make it as a primitive attribute. Okay, next I'm going to create another attribute for the primitive, and that is going to be the actual pipe size. So pipe radius or diameter, whichever it is, probably diameter pipe, or I don't know, maybe I'll just call this pipe size, and float. Yeah, so I have two information to define the size of the pipe and how much it's being offset for each grid. Okay, now going back inside a loop, I'm going to define the actual offset value. Okay, so to do that, I'm going to use the primitive wrangle. Okay, let's call this offset value. At this point, I'm just going to calculate how much I want to offset and not going to move the point immediately. I'm going to do that later. Now, let's see what kind of information I need to have. Well, first of all, let's see. Well, first of all, I want to define how the size of the pipe for sure. So let's do that by using some random value. The scale of the pipe could be random, so I mean the radius of the pipe could be random, or maybe based on some multiplication of the original thickness, meaning original size of this plane. So the original size of this plane is currently inside a primitive attribute called p scale. This is the size of each grid. So maybe, and so the pipe size should be less than this size for sure. So let's have that information first. Plane size is at p scale, and I want to make the pipe size random. I'm also going to get the iteration value from the second input, just like I did previously. Okay, now let's create some random value using this iteration, rand iteration multiplied by some random value plus seed. Okay, let's change this value a little bit to okay, and now you get a value in between 0 to 1 here, and I want to convert this into probably a division number to divide this p size. So let's make this an integer value. I'm gonna make a value called div num and convert this random value in between 1 to the maximum number of division. Okay. Like that. And then finally, I can use this value. I might need to use rint to convert it into an integer. Then I'm going to use this div num to divide this original p size to give a final pipe scale, pipe size. So the pipe size is equal to, let's rename this to plane size. Plane size divided by div num. And probably I could also apply some additional multiplication to scale this in between 0 to 1, so that in some case the pipe, it's not going to fill the every plane, but the pipe could be smaller. So let's create pipe size multiplier. something like that. And let's start off with 1. Okay. Now that should give you the pipe size. Let's have it, let's apply it to a primitive attribute, pipe size. Also, I'm going to apply this value to the offset size as well. The offset size is more of a iterated, incremented pipe size value, which is going to be incremented on each loop when you see other strips on behind. So start with the original pipe size. Okay, hello everybody. and I'm not sure if I need this information, so I'm just gonna leave it for now. Maybe I might need it later, but let's leave it for now. Okay, so now I have the pipe size and the offset size here. It's time. I could next thing I need to do is to transfer this information, like something like pipe size or offset size, to the original guide geometry so that I can use it for the next loop. Okay, so let's do that. I am going to use another primitive wrangle to pass those information to the guide geometry. I'm going to specifically choose the guide geometry to pass the information, and the information that I need is the offset value that I have created here, or pipe size value that I have here. Okay, now going to first of all look for the same grid in the same position, the grid and the same position. So the original guide geometry has those grid, and the strip which has been created from the guide geometry has the same position. So you could get the corresponding primitive number for each strip grid by using something like XYZ distance. So I'm going to use XYZ distance, looking at the second input, using current point position to search, output primitive number and UV. And this primitive number is going to be the corresponding primitive number for each grid, which corresponds to each grid on the guided geometry. And if the distance is close to 0, that's where you want to transfer the value. So I'm gonna create the conditions if the d is close to 0 or close or equal to 0, then copy the offset size coming from the second input. Same for the pipe size. Okay, this is not enough. Oops. The function has to be prim uv. Prim uv. Okay. So transfer offset value. Okay, this is just information that I need for each iterations. Now let's think about how I actually offset the geometry. So to test out, let's make the loop to 1 so that I have only one strip to test, which is easier to see. Now going back to this information, kind of a C2 strip, which is fine. I'm gonna just offset those two strips simultaneously. And to do that, gotta think how I'm going to actually move the geometry. So to move the geometry, I want to calculate the offset value for each surface strip on this direction, on this direction, and so on. And for example, for this direction, I don't want to just, even if this plane is touched with other strip, I don't want to just offset this plane, this single plane, but I want to offset the whole surface, including these one. So even if it's touching just one strip, it should affect all the plane to offset to make it look like it's been, the angle is 90 degrees based. If I make it possible to just offset one plane, then the angle is going to be messed up. Like you might going to have a diagonal angle like these, which might be okay at some point, I mean in some setup, but for my conditions I want to avoid that. But you could try it by yourself. But for me, I don't want that to happen, so if it's touching even for one strip, then I want to move everything all together in with same value. So that's the rule that I want to set. So to make it possible, and I'm gonna do some preparation for that. So first thing I want to do is to define how much I want to move for each surface. Okay, so to do that, you need to check how much you need to check whether you have a intersected strip previously created by this loop. And in order to check, you can check to this guide geometry, and this guide geometry has the information such as an offset size or pipe size, and referring to this information, you would know how much you need to offset. Okay, currently it's 0, so nothing happens, but let's create the setup for reading those information, shall we? So let's do that by creating another primitive wrangle and try to read the information from the guide geometry. Okay, starting to get a bit complex here. Read offset value from guide. So just like you did here, when in order to transfer the offset size from the strip to the guide, here you're going to read the offset size and the pipe size from the guide to the strip. Okay, and increment the offset size so that you know the actual offset value, how much you want to offset from the original surface point position. Okay, to do that, another vex that I need to write, pretty similar to what I did here in order to find out the corresponding grid information from the guide. I'm going to use the XYZ distance. So float the XYZ distance. Looking at the second input, the group name is guide, and you're using at P, the center of the primitive, to search, and as an output you get primitive and UV. Alright, now let's assume the primitive is more or equal to 0. If it's negative, then I think I'm never gonna get negative in this situation, so maybe I don't really need to use this. Now I have the primitive number and the UV. I can now get the offset size value from the guide, which is the incremented offset size from all the other strips. So total, I'm gonna call this total offset size, getting from the guide geometry primitive. Okay, and I'm going to update the current offset size of this strip by adding this total offset size retrieved from the grid, the guided geometry. Okay. Yeah. And that should increase the offset size. But currently the offset size coming from the guide geometry is equal to 0, so it's just the own offset size defined by this calculation. Okay, this is going to work after second iteration, I think, when you have found any intersections. Okay, now next what you want to do is to I want to use this current strip offset size to be used as the actual offset distance to move these plane on perpendicular direction or normal direction. And there is a chance, in this case, there is a chance that only this plane has a high number of offset value, and these plane could be 0 if there are no intersections or smaller than this one. But as I said, I want to move every plane on the same side to move in same offset value. I want to move in same distance. So I wanna get the maximum offset size out of all the plane which is in the same side, and use it as a final offset size value. Okay. So to do that, first you need to group each side separately. For example, these four, or just this one, or these two, one, and one, and these four, and so on. Okay. So to do that, you need to make some connection information to these strip. Okay, so let's think how we could do that. Well, first of all, we need to split these plane. Currently, everything is connected like these, but I want to split it into the side pieces, side by side. So I could use like something like face component or node to cusp the polygon 20 might be fine. And if I double click it now, it's being separated into each side. Looks good. And after this, I could use a connectivity node to name each side with a class attribute. Class or any value you could name. Class is fine for now. Okay, so if I look at the primitive attribute, you should have this class, and this class indicates the number of the index or the ID of each side. Sometimes you have only one side, sometimes you have multiple number of primitive as one of the side information. Okay, and now you could use this information to get the maximum value for the offset size on each side. So I could use attribute promote to for the primitive to the same primitive, I could get the maximum based on each side, in this case based on each class attribute, which will pick the maximum out of 4. In this case, for this side, if this one has an offset size equal to 1 and this one has 0.5, this attribute promote will get the maximum offset size, in this case 1.0, then use it to map it to all the face which shares the same class. Okay. And then we could use that to actually offset the surface. Alright, that's my plan. And let's see. Let's try to actually offset this. Now, in order to offset using this value here, it shouldn't be separated anymore, because I want to move, if I'm moving this surface, I also would want to move these edge connected to this edge here. So I should use fuse again to merge all the points together in order to offset by connecting all the edges. Okay, so let's actually create the offset function. Primitive wrangle And do I need any other information here? Probably not. So, or let's name this strip offset. Okay. So I need two information. One is the offset size. This is the actual. This is the actual offsetting value for the surface, and we also need the pipe size, which is also used for the offset, which is being used as a pipe radius or pipe diameter. Okay. So we need to get two information. One is the offset size. One is the pipe size, which both are inside the attribute. Alright. Now, in order to offset, you need to access to each of the point. So let's get the point position from the primitive. Prim points. Okay. And it's actually time we create an offset. Okay, so let's do that. Let's make a loop. Accessing all the points on each primitive. Get the point number. Get the and now I'm going to update the point position using set point attrib 0 p, and the direction that I want to move is the normal direction of each face. Hopefully each face has its normal direction. Let's check the geometry spreadsheet at the primitive, and if I have n value, should be fine. These values should be used to offset the to define the direction. Oh, where did my loop go? Okay, it's been deleted somehow. Loop through all the points, get the point number, update the point position, and with a normal direction multiply by the actual distance you want to offset. So that will be the offset size minus the pipe size multiplied by 0.5. Wanna this is the pipe radius, this is the actual offset size based on the strip created previously. So hopefully this will work, and finally I'm going to use the add option to increment the offsetting. Now I have some problem here. That is because here I'm adding like 3 because I'm updating this primitive and this primitive individually. you have two updates here. Same for these. So that's not good. It's not really good. So in order to avoid this, let's make the side face as one primitive so that I'd only have one primitive on one side, combining all those grid as one surface. This will make my life easier, hopefully. So to do that, I could do that before. Where should I do that? So this is where I'm calculating the maximum value, so I should do that after this. So okay, after getting the the maximum offset size for each side, I'm going to combine all these grid, which is currently still be separated because it's before fusing. I'm going to use the divide node to merge all the faces together like that, but it still has a point on the side. If you visualize the point, you see those points here. So also want to delete that by using another face node with an option called remove inline points, which should remove the inline points just like that. Okay, so hopefully all the side has only 4 points. Okay, just like that, and so on. Okay, looks good. And now you can now fuse it and offset it, and seems it's okay now. Everything is offsetted cleanly with the amount of pipe size and the offset size, I think. Okay, hopefully that's good. And now let's combine it with here, replacing this merge with this final strip, and see what happens. So this is one strip. If you increase the iterations, going to have a number of strip here and there. And let's look for some intersected place, and there you go. This is where the this plane is intersecting with this one, so it's being offsetted outward a little bit more with amount of pipe radius as well. Okay, and if you continue doing that, going to have somehow it's trying to avoid intersecting with the plane, but there is a chance that the intersections like these happens. And with this setup, I cannot avoid having this kind of intersection, so you need to think of additional logic for this one. Maybe you could delete these or do some other logics with these situations, but for this setup I'm just gonna leave it as it is. It's not smart, but at least it gives you some kind of visuals, so good for starting point, I guess. Yeah, having intersection like these might not be really good, but let's just leave it. Okay, so let's see if I have another information to give. For now, I think we could start trying to convert it into a pipe, because I already have an information like the pipe radius for each strip and the pipe strip information itself. Okay, so let's do that, shall we? So I am going to pick, so start off with just 10 loops is fine, I guess. Having all these set up. Let me also organize some parameters that I could transfer to here. Something like random seed and so on. So let's check what kind of parameters that I made. Nothing here. So this one, okay, so I have a random seed. This could obviously be one of the value that I could use to change the shape. And you have another seed here. I guess you can just use the same seed value here. Applied it here. No meaning to have multiple number of random seed. And maximum division, yeah, I could bring this here. Maximum div number, pipe div number. You are also having pipe size multiplication value going from 0 to 1. Okay. What else? This doesn't have a parameter. This doesn't have a parameter. This one also doesn't have any parameters. So not much. Okay, just these. Okay, so accept. Let's try changing the parameter. See the effect. First of all, the random seed. So you're seeing randomly selected strips. Okay, and by changing the pipe size multiplication, you're seeing how much it offset based on the pipe size. Okay, also this will affect how much it offset as well. Okay, now let's actually create a pipe then. Hello Ori, by Midjourney runway image to video is amazing. Do you think that we have to give up the FX? Do you recommend me to try something else? I'm 16 years old. Yeah, I mean, I've been watching those technique in Twitter a lot, and those looks really amazing. Yeah, I'm not sure what's gonna happen in the future. Those like AI tech will just gonna give the possibility to make every effects that used to be made procedurally or by math easily by just using a prompt. So yeah, creating those images, movies could be really easy in the future. So you might really do not need to learn those mathematics or procedural stuff at all. Maybe sometime in the future. But at least it is fun to use your brain to think how things work logically. So maybe those process is not really necessary for production, but at least as a puzzle, it's still is fun, I think. Think it as a other language to learn, or could become an ancient language just for intellectual purpose, but still should be fun. Okay. Where was I? So let's convert this strip into a pipe, shall we? So in order to make it as a pipe, I'm going to convert each strip into a bunch of lines, polylines. Okay, so primitive, wrangle. So in order to convert these strip into lines, you need to define how many divisions how much you want to split this into lines, and the thickness of the pipe, and so on. The thickness of the pipe is already inside a geometry spreadsheet, which is this one, pipe size. This is the diameter of the pipe. So I could use the half size of this to set it as a radius, and that value could be used to define how much pipe can be aligned in this edge. If the edge size is equal to 1 and the pipe size is equal to 2.2, then the maximum number of pipe which can be arrayed on this side is 5. 5 multiplied by 0.2 equal to 1. So you could kind of define the maximum number of pipes by dividing the edge size by the actual pipe size. Okay, so let's use that method, shall we? First, I'm going to get, I need to get the edge information of this side and this side, which is being connected to the other primitive. Okay, so we need to have that information. We want to have this information and this information so that I can divide each edge by specific number of value to create a lines in between those two edges. And the only information that I have now in order to determine which edge that I want to pick is these connections, the neighbor connections. So I could get those information by accessing to a half edge information. So let's do that. Starting from a initial half edge information from the primitive, which could be randomly picked, so you don't know which edge is being picked initially. Could be this one, could be this one, could be this one. Oh, there's many possibilities. So you need to go through at least 4 loops in order to check all the edges, which edge has the neighbor and which edge doesn't have a neighbor. Alright, so and you also need to have a edge size, which can be accessed by p scale of this primitive if it's still alive. Yeah, it's still alive. So this p scale came from here, at this point, which is the size of the grid, the size of the voxel, I mean. Okay, so let's make a loop to check all the edges and if the edge has its neighbor or not. Okay, so int. So I think I'm looking at this. Whoops. I'm looking at those quads. Everything is in quad shape, so there should be only 4 points for each primitive. So I should only look for 4 edges, hopefully, if I'm not doing anything wrong. And I'm gonna go around the edge. If I'm starting from this edge, look for the next edge, and look for the next edge, and look for the next edge. Okay, and to do that, you can use a function called hedge next. Okay. Now, why am I having error? Okay. So the hedge next just give you a next edge from the current half edge. And you could also use other function which is called as hedge equivalent, no, next equivalent. Now this will give you the neighbor edge. If I'm looking at the half edge which belongs to this primitive, where the start point is here and the end point is here, and if this end edge is the one for that edge, then the next equivalent half edge for this half edge is the one belongs to the neighbor primitive when the start point is here and the end point is here. So the end point and destination point is being flipped for the next equivalent. And if you are looking at this edge, the half edge starting from this point to this point belongs to this primitive. And if you calculate the next equivalent half edge for this half edge, the result you get is the same half edge which belongs to this primitive. So starting point is here and the end point is here. So you could check whether the half edge is equal to a equivalent edge. And next equivalent, if the next equivalent half edge is equal to the half edge, then that means you are in this corner, which doesn't have any neighbors. If it's not the same number, then that means you're at the neighbor edge. Okay, so I want to look for the where the neighbor I want to look for the neighbor edge which has the neighbor primitive, so I should look for this condition. The half edge and the next equivalent half edge is not equal, meaning you have two different half edge here. One belongs to this primitive and one belongs to this primitive. Okay, now I could now get those information, which in this case I want to get the starting point of this half edge and the end point of this half edge for this one. So how do I get that? Maybe I could create an array which I could then use it later. So how do I name this? SBTS stands for the point for the starting point, or maybe I could just create an empty point array and just append the starting point and end point here. So the starting point of the half edge can be retrieved by how? Edge point or edge point or edge point, what was it? Edge destination point or starting point, yeah. So I want to get the edge source point. This is the starting point of the half edge. So get that. And let's also get the end point, which you can get that by using destination point function. Right, now append those value to the point array. Okay. Now in the end, you should have 4 points being stored in this point array, I think. Let's check that. Oh, and I also need to update this edge value to the next edge so that I can look around all the edges. Yeah. So let's see. I'm going to check all the point value. See how it looks like. And if you have 4 point number for each primitive, that's a success. And this should be in either clockwise order or counterclockwise order. Not sure which order that is, but at least the first two belongs to a edge which has the neighbor primitive, and the second two set also belongs to the edge which has the neighbor primitive. So that's the information that I need. Now I can loop 2 times, or I could just create in this case I need to calculate the number of pipes that I want to create now. Alright, so let's do that. First, let's define the pipe size. So the pipe size, I can call it as p scale as f at p pipe size multiplied by 0.5. Considering the pipe size is the diameter of the pipe, you should multiply it by 0.5 to make it as radius. Okay, now also want to create how many number do I want to divide this plane. So and the maximum size of this edge is this. I'm gonna call this edge size. And so edge size divided by p scale should be the maximum number of divisions. And let's use the floor, and probably a maximum 1. So at least you have 1 pipe. Okay. Should do it. Now this is the number of pipes you want to create. You can now use it to create the loop. Which defines how many pipes you want to create on these stripe or strip. Okay, so next next thing you want to do is to define the point position for each pipe, and you have to divide the edge by a number. Then you also need to consider the p-scale and also need to consider the point position of the edge. So let's first get the point position of the edge. Okay, so I can do that outside the loop probably. So let's name it s plus 1, e plus 1, s plus 2, e plus 2, and I will already have the answer to those position. S plus 1 is 0.0 p at PTS 0. This one is 0.0 p PTS 1. I think I can make it a little bit more easier, making a nested loop to access to those points. Vector e plus s plus 1 is equal to 0.0 p PTS, in this case 3. And finally, the end position for the second edge is 2. So if I have a grid like this, currently I have P0, P1, P2, and P3. And I have currently set this one as S plus 1, this one has E plus 1, this one as E plus 2, and this one as S plus 2. And I want to connect these two positions and divide it by a number of pipes I want to create. And those separation values should be defined by the pipe radius. Alright, so now that I have those 4-point information, I think I can make an array here. And I think I could gather those starting point position as one array, these end position as one array. So S positions S plus 1, S plus 2. E positions E plus 1, E plus 2. Okay, now I can make another loop. Well, in this case I only have 2, so I can just say 2. Then I could get the S pos, which is, wait a minute, actually this doesn't really work, is it? Well, it does work somehow. Let's just try. doesn't work, I'm gonna rewrite it. E positions. Okay. And now I'm gonna try creating a initial line. Connecting the S position and the E position. Although I need to update the value a little bit based on this I later, but for now, let's see how this works. Okay, in order to do that, I also need to create the point. Wait a minute. After all, this doesn't really work. Sorry, but this doesn't really work. Because I need to lerp between the start position 1 and start position 2 in order to get the in-between point position. So it doesn't really make any sense having additional loop. So sorry for that. Okay. So this could be calculated by starting from the S position 1 plus, first of all, you calculate the vector from starting position to the end position by subtracting those two vectors, then divide it by the number of divisions you have here, then multiply by the iteration here, plus 0.5 to have a initial offset. Okay, let's see if this works, and do the same for the end position 2. Is this correct? Yeah, I think so. And all the other is fine. Now let's create the point to those S position and end position, and connecting those 2 points together. Okay, something went wrong. Something funny is happening. Okay, why is this? Okay, something must be wrong here. Let's see where. First of all, this one has to be 2. Yep. And it seems like the offsetting direction is wrong. Okay. Maybe I need to make this negative. Alright, now the line is on top of the plane. Looks like it is. Okay, looks good. And now that I have these lines placed on the plane, it's time I set the P scale as well to each point, which is going to be used as the pipe scale, the pipe radius. So P scale P scale. Okay. Okay, and now I don't really need the strip anymore, so I could delete that. Delete the original strip. and I am only left out with those pipe lines. Okay, let's see how this goes. Next, I'm going to fuse those lines that I've created to connect all these together using the poly path as well to connect all the separated curve into one using the poly wire to create a pipe. And the radius is p scale. I could increase divisions and I could check whether it looks okay or not, and seems like the pipe radius is a bit too big. Looking at these, it's been self-intersecting, so maybe something is wrong. Let's check. So the P scale is currently the pipe size of this half size of this pipe size, but I realize that I need, for this divisions, I need to use this pipe size, the diameter, instead of the radius. So I think by doing it, and I think currently I have a cache here, reset the cache. Now the radius looks better. Obviously that this pipe is intersecting with other pipes because this is really thick, and this is the intersection that I cannot prevent, but I could at least make it a little bit better by going back to the parameter, making the pipe size multiplier smaller, or making the divisions larger, making this also a smaller value. Having smaller number of pipes, so at least you do have some avoidance somewhere around here or here and here. So some places do have some weaving effect like I want it, some place not, like these or these. Oh well. So it's not really perfect at all, but at least it worked at some point. So next thing I would like to do is to make the corner a little bit roundish, because currently it's a bit too straight. So let's make it a bit rounded, and the easiest approach that I could think of is to use the smoothness in this case. So let's first, before doing the polypath, I'm going to use the resample to add multiple number of points. Maybe I should do that before using the fuse. And make this number small enough. I'm not sure what's the best number for these. It's also checked resample by polygon edge, so that it's not gonna create any unnecessary resample on the corner. Now you could fuse it, and you could use the polypath, then finally use the smooths to create some roundness on the corner. Right. Now the round, how much roundness do I need? I'm not really sure. It depends. It's a balance between the number of points that you created using the resample the amount of smoothness you set here. If you want to make this as an arc shape, then you have to do the other process. You might need to trim some amount of curve here and replace it with some arc, the real arc shape. But the easiest approach is to just use smooth. And there is some problem because it's been inflating a little bit here, so you might need to have more numbers of points in order to avoid that. We'll use other types of smoothness. Well, anyway, in this case, uniform works fine. I'll just go with this for now. Okay, at least if you look from far away, it looks like it's been an arc curve. Well, it's pretty fakey arc. Okay, not bad for visual. Okay, so and if I increase the number of iterations here, like 50, I'm going to have more pipe strip and some interlacing fine, some intersecting a lot, so depends on which intersected first, so on. Control how much divisions you want to have here and here. This mostly indicates the separation between the pipe. If you make it 1, you are using the whole grid to separate the point. If you make it smaller, you're going to have some space in between the pipe a little bit. But now that I think of, maybe making it maybe I could tweak some algorithm in order to define the pipe size a little bit more to avoid having those too big. Oh, and I do have some problem here. What's happening here? That might be related to the polypass. Nope. Okay, let's see what's going on here. So maybe probably due to a fusing a necessary point together. So if I make this value smaller, yeah, that should solve the problem. Okay. Well, okay. So let me update the pipe size part a little bit. See if I can make it a little bit better in terms of the size. Not sure if I can, but let's see. So where was it? Where did I set the size? Yeah, somewhere around here. So first of all, I have set the minimum like pipe division to 1, but if I change this, the minimum pipe division becomes larger, so probably I could also have this as a parameter. Naming as min div. Okay. also, considering the, I'm gonna check. Okay, so I do have tons of offset here, and it's a bit hard to evaluate. Sometimes there is some offset which doesn't really look like it's being affected by the previous offset size, so maybe something is not working correctly here. Let me check. But first, let me transfer this value to the controller. So, where is it? Where did I set it? This one. Okay, let's name this min pipe div, min pipe div. Okay, so let's debug the current situations. So this, I think D strip and D strip should never be intersected in this situation, so maybe something must be wrong here. So let's go step by step. Okay, so let's check this one. So so I have here, and I'm getting this strip. Okay, and what am I doing here? So I have in this case, in this step, I have just get the strip, and then I am getting the offset. I'm creating the offset value, how much it should offset here. Currently it's just the pipe size. And how much size do I have here? Okay, these are the size. And if I look at the guide geometry, which corresponds to this position, let's pick those position, see how it looks like in terms of attributes. Okay, so okay, I have offsets. It looks wrong to have 0 as a value here, because everything must be incremented one by one, so must be wrong. Something must be wrong here. Okay, and if I check, as you can see, everything is being wrapped, so nothing has to be 0, either this side or this side. So obviously something is wrong, and I realized I have to transfer this offset to the guide from where I have calculated the maximum offset size. So it has to be calculated after this. I have to transfer the offset size after calculating the maximum to here. That's what I need to do, I think. So replace it here, and there you go. You have, looks like more unintersected ribbons or strip. There you go. I think this looks more like it. Less intersections. I do still have intersections like these, but these are not, these are unavoidable. I mean, just because it's coming from the other side. But all the other sides, I think most of the things are working now. Let's see the result then. Okay, looks more like it. What the? Okay, there is some weird thing going on at some point, but overall looks good. Avoiding the unnecessary intersections. Well, there are some, but moreover, much better than the last time. Okay, looks good. Now let's see some weird point that I saw last time. Where is it? I think it was like this parameter. Okay, here. What's wrong with this point? Huh. Ah, okay. So it's been self-intersecting. Okay, this is a bit hard to avoid. So in this case, after having the pipe curve, I'm having like something like these. Okay. Now this is a bit hard to solve. So maybe I could, let's see. If I check each line here. So probably I could just remove those two small edges. And if the edge is less than the radius or diameter of the pipe, then maybe I don't really need to have that. So maybe I could remove those edge which the size is too small. So in order to determine if it's too small or not, calculate the parameter, use the primitive wrangle to check whether it is smaller than the radius. If the perimeter is smaller than and the radius is set as p scale point attribute, this one, so let's promote that to primitive attribute promote. Point to primitive, don't delete the original. P scale, get the average, it's fine. And P scale, then remove those primitive, remove prim. This will give you an endpoint like these, but better than the last one, I think. So let's see the result. So you do have an endpoint like these, but at least better than the last time. So okay, so far so good. Now if I make this without the okay, so there are some split here, but same reasons. Okay, so next thing I would like to have is those joints for the pipe. Okay. Okay, I have a question. Can this pipe avoid intersections? So as I said, there are intersections that I cannot avoid, and there are some intersections that I can avoid. Now I have already implemented the one that I can avoid in this setup, but and some plane. In this case, I'm just offsetting the strip in normal direction. That's the only things that I'm doing. There are unavoidable intersections like these in some case. So in those cases, you need to have another logic to avoid, or I don't know, delete specific positions or things like that. So I'll leave that to you because it's gonna be a bit more complex to make another logic on top of this. But I mean, there are many ways to do that. I think it's up to you. It's up to your imagination how you want to avoid it from here. And there are, I mean, you could start from the start. I mean, the way I got the strip is just using one plane, but you could probably use multiple planes to create more of a snaky like strip, not as straight directional strip, but could have like T-shaped strip or L-shaped strip or something like that to make it more complex in terms of the connection. So it's really up to you how you want to make it as the next step. I'll just leave it as a basic initial starting point to give you a space for the update. And if you do that, if you made any update, then let me know. Okay, so let's create the joint. I'll just make the joint where you have a corner somewhere on here, and so on. Okay, so in order to check where you have the corner, I'm gonna go back to somewhere around here. Where I have made pipes. Then make each edge a little bit smaller in both directions. Trim each curve like with the same amount of distance, just like you do in carve. But using carve, you cannot really define the distance how much you want to trim for each curve unless you use for loop, which is too slow. I'm gonna use primitive wrangle again to trim the curve by importing the external function called groom. I'm gonna read the external file called groom, which include the function called adjust prim lengths, which you could use to trim the lengths of the primitive by a specified length. So in order to use that, you need to also have a current primitive length and multiply the parameter by some ratio you could trim the curve. Now I want to define how much I trim by the length, so first create a parameter to define the length, then create the ratio by dividing the current parameter, or just subtract the current parameter by this trim length. Okay, and replace it here. Okay, and this will enable you to trim in constant distance. If you want to trim this part here, which is the starting point position, you need to flip the curve in order to trim this part. You are trimming from the end point. The adjust trim lengths only trim from the end point, I think. Even if I change this here, doesn't really make any sense. So in order to trim on the back side, the other side, you need to flip the curve. In this case, using reverse. And do the same process that I did here. And recalculate the prim edge, and there you go. Okay, so trim, and let's just copy the code itself because I'm just doing the same thing. Just gonna paste it, then also copy the parameter for the trim, paste it here. This is so that if I change some code here, this will be updated as well, also the parameter. Okay. Now there's another chance that this trimmed curve becomes really small again, like in this case less than 0, I mean smaller, close to 0. In those cases I don't want to have the joint there, so let's recalculate the parameter and remove those primitive when the parameter is really close to 0. Okay, so some parameters should be deleted. So currently I have 2698. Previously I have, same, so maybe that was okay. But if I increase the trim value, then it's not been deleted, even though I should have. Okay, I need to make sure that I don't go over the length of the original parameter. So in this case I should make sure this doesn't go negative, so I should make it max 0. Yeah, that should do the job. And now still not being calculated correctly. Okay, perimeter. Am I reading the perimeter correctly? Not sure. So okay, so this, I do see a lot of zeros here, so this should work. And if perimeter is smaller than 0.01, should be deleted. Okay, maybe I didn't need the space here. Alright, now that should do the job. Okay, now what I want to do next is to place a joint cylinder on the end point of this curve. Okay, in order to do that I also need to set a normal value to each point. so let's do that in the end. Okay, so, or maybe I could just use orient along curve node to create the normal direction as a tangent vector. Yeah, this will just do it. Now, I also need to set the p scale, what's the size of the joint, which should be derived from the original p scale of this pipe. So does it still have it here? So somehow the p scale has been changed when I did the trim. So I need to retrieve the original p scale, which should be alive till here. Or is it still alive here? Not sure. Maybe I can try. Let's create a cylinder. Cylinder or tube. The radius is equal to 1. Let's make the end cap. Let's make the height a little bit smaller. Something like that. And make this z-axis and use copy 2 points to place the cylinder to the end point of this curve. Okay, now I think the point is missing p scale. Okay, so it looks like everything is 0. Where did it end it? Okay, after I have used the delete, seems like everything becomes 0. So let's transfer this p scale. I think if I will promote this p scale to a primitive temporarily, this is gonna preserved, hopefully. So I do have p scale after trim. Yep. Even after delete, yes. And finally I could make this back to an point attribute. Somewhere around here. From primitive to point. There you go. Now this looks like a bit too large. Let's check. Combining the pipe and the joint. Actually it was the same size as the pipe, so I might need to make this cylinder a little bit bigger. The radius scale to 0.1. I don't know, 0.2. Make the height a little bit higher. 0.5. Okay. And now you could also change these trim parameter, how much it close to the corner. Okay, starting to look like it. Okay, well, I do have tons of intersections here, so it will be better if I could avoid it for sure. Okay, at least until here I have made it, I am converted procedure converted the geometry into a pipe network. Alright, so let's see. Let's give some there's some shift here. I think it's due to the deletion that I did somewhere here. No, somewhere. Where did I do that? This one. Okay. So if I remove that, this will give a diagonal shape, but this will also give a chance to have this kind of shape. Those diagonal shape might be okay, like these one, but I do want to avoid these one, self-intersected part. Now, how do I determine that? It's not just the length, I guess. So if I look at here, it will be great if I could just trim out those small areas. Well, it's been really hard. Do I have something that I could use? Yeah, I think there was a labs curve or lab split. I think there was some node coming from the labs to split the curve. Forgot the name. Boolean curve, maybe this one, but maybe not. Forgot. Totally forgot. But the Boolean curve should have some hint inside. Okay, so self-intersection. Okay, this one, so intersection stitch. So combining those two should give an option to should be able to split the curve into two. Let's try these. I'm gonna copy and try that with this curve here. Connecting here, connecting here. Let's check. Nope, it's not being trimmed. Okay, it's not intersecting. Okay. Somehow, I think I need to do like this. Okay, now it's been splitted. Why do I have things like this here? Huh. The intersection point is not really correct, is it? Oh, but I do have points here, so maybe I should do that before resampling. now seems to work. What's this? Okay, so do I need this? Yeah. Okay. So I think this will split those curves, and now I could and what was that for again? Hmm. Let me try connecting these to here. Still removing the curve, so give a nice corner. But it still has a problem on these side. But I guess I could fix that by tweaking these P scale by, I don't know, 0.5 or something. Yep. But not here. Okay, well, then it's either you delete or not. So maybe this is not really necessary after all. Okay, well, that's that. Groom H is specific library function. This is not specific vex syntax, look like more C++. Yeah, it's being I think it's being written for hair related function node. There's a groom related node which belongs to hair based node, I think. And if you look for the Houdini directory installation directly, there's a file name called groom.h which has some functions written inside using the vex syntax to trim the curve. So I'm just reading those functions by reading the groom.h to access those functions like these. Which is not really written as C++, it's just written as vex, another vex. So if you look for this file, which should be found on the Houdini installation folder, you should be able to see the source code of this adjust prim lengths. Okay. So let me think if I could deal with this kind of intersections a little bit more. I'm not sure if I can, or just want to check. So for example, like this one, at least I could see if there's an intersection, and if I have an intersection, I could just delete those lines. That's possible, I think. But that's not a straightforward, I mean, that's not a like clean way to fix. If you really want to avoid intersections, then you need to rethink how the you need to rethink the pipe alignment itself. In this case, I'm just offsetting the strip retrieved from the original geometry. So if the offset size is really big, then at some point you are getting intersections like these. So if you really want to avoid intersections, then you really need to rethink how you create the network from scratch. The way I did is not really applicable for that, because I'm doing it one by one like these. And the only operation that I'm using is this offset. So you need to update this part to make it more smart to duck the current strip, which I'm not doing it. I'm just using some metadata like offset size and so on. So if you want to make it smaller, you need to update here. And you could probably do that in some way, but the way to offset might be really hard. To offset the surface cleanly might be the hardest thing. At least you do have a bunch of strips and guide geometries retrieved from here or here. So you could use it as a guide to create an offset for this strip that you retrieved. So should be possible, but it's not that easy, I think. Yeah. So I'll leave that to you. I mean, if I have time, I'll do that sometime later, but maybe not today, because I know it's gonna take some time. I don't know, additional 2 or 3 hours. And it's already 4 a.m. in Japan time, so I think I need to wrap this up in this timing. So let me try out the final pipe setup with all the other geometries also being cheaply rendered using Principal Shader. Let's finish this live stream. I'm gonna create a matte material, create the Principal Shader. I don't know, make it white. Use Principal Shader. Let's also set some environmental light with some, I don't know, background texture. Let's hide that. Okay, and looks overall okay. I mean, if you look from far away, you don't notice much intersections. Well, I do here, but and let's try all the parameters that I have set. Something like minimum pipe divisions, maximum pipe divisions, pipe multiple size, okay, probably I need to also create the normals. There you go. And so on. 2, 6. Hey, nice. And what's happening here? This this doesn't suppose not to happen. Probably again it's due to these removal code. No? Where does this come from? Oh, what's happening here? Okay, resample is doing something wrong here because of this intersection stitch. Okay, then I'll just remove it. Okay, forget about using these. Okay, not bad. And if I increase the iterations like to 100, you're going to have much more wrapped up version. Okay, I think this iterations could also be a parameter, so let's bring that up. Which is same as strip number. Let's make this maximum 100. Okay. And if I change the voxel resolutions like to 10, you have a bigger voxel size. If you make it larger one like 40, you have more high res geometry or voxels, and you might need to have more strip numbers to wrap it up. Okay, combining with all the other parameters. Okay. Not bad. Okay, now let's try with other shapes like pig head. To see if it's gonna work. Yeah, and as long as it is closed geometry, which can be converted into a volume, should work. Now again, there's some funny things happening here. Let's debug that. Where does this come from? Huh. Okay, some weird things happening here. What's this? Okay, some offsets are not working correctly, so probably I need to fix that. That's probably where the error is coming. That's where I don't have a primitive which the point number is not equal to 4. So for a primitive which doesn't have a point equal to 4, maybe I can just ignore that. So if length PTS is equal to 4, that's the only primitive that I want to use to create the pipe. And everything is gone, so why? Let's see why. Oh wait, no, what I need to check is the prim points length. Yep. Okay. Now, yeah, this should fix the problem. Okay. There you go. Okay, let's try with other geometry. Scav, squav. Now this obviously needs a lot more voxels in Z direction. So let's increase the resolutions like 80. There you go. Not bad. Yeah. So should work for any geometry if it's closed. Let's give a switch node so that I can switch between those geometries. If I use 80 for the rubber toy, seems like the resolution is a bit too high. So in those cases I need to probably reduce the smoothness and increase the value for the resample to make this cornered. So in this case I'm going to reduce the, so probably I need to make those smoothness and the resample length as additional parameter. Yep, so let's do that. Connecting here. And finally the smoothness. Okay. Oh, forgot one thing. I also need to bring the joint distance. Just this one. Pipe joint, I don't know, offset. There you go. Okay. Let's try with high voxel value. And try changing the resample length to smaller value. Yeah, which should make this more straight. A little bit more. And reduce the smoothness. Yeah, like that. Okay, so it's been proven that this works. Let's make this back to 20. And for voxel size equal to 20, I don't need to have such resample lengths. Let's make this back to 0.2. Smoothness to 10. Oop. 0.02. Okay. Should do it. And the strip number 2, I don't know, 40. Okay, so that's probably it for today. I'm not sure how much it feed your interest, but hopefully you found it somehow interested. It's not really a perfect way to pipelify the object, but at least this could be a start, one of the starting point to do the stuff. I think there are many directions to go from here, so hopefully you find it interested. So that's it for today. Thank you for joining. Let me know if you have any questions or feedback or anything. If not, I'll finish the live stream here. As always, I'm going to upload the file, and you could access it from the video description page or the Patreon page. Everything will be uploaded as freely, so you can just use it for your own purpose for free. But if you found it helpful, if you want to support me, there's a Patreon page of myself, so if you could support me there, that would also be great. if you feel like it. Okay, that's it for today. I'll do another live stream next week, same time, so hopefully you could join it. Thank you and good night. See you next week.